My dear students, in this video we are going to study the image formation by spherical lens using the lens formula, and we will also study what is the power of a lens. So if you remember the formula for the mirror, we had three parameters. What we call is the object distance u, image distance v, and the focal length. The formula for the lens also is similar, except in the spherical mirror case we had 1 by v plus 1 by u is equal to 1 by f, but in the lens formula is different. There is a difference. 1 by v minus 1 by u is equal to 1 by f. Again, I am not going to derive the lens formula because this is not part of your syllabus. So you need to remember the formula 1 by v minus 1 by u is equal to 1 by f, and this formula is valid for a convex mirror and concave mirror. The only important point is you have to take care of the sign of different quantities, as we have seen in case of a mirror. So while solving the numerical problem, you have to ensure that the sign of focal length is correct, sign of the object distance is correct, and the sign of magnification is also correct. Now the next formula is for the magnification. So if you recollect, in case of a mirror also, we define magnification as the ratio of height of the image divided by the height of the object. So again, this is denoted by a symbol m, and what is this m? Is the ratio of height of the image, which we denote by h prime, and the height of the object we denote by a symbol h. So this m is the ratio of height of the image divided by height of the object. So the formula is m is equal to h prime divided by h. Again, this magnification is related to the object distance and the image distance, that is v and u. So in case of a mirror, if you remember, m was equal to h prime by h, and there it was minus v by u. Here it is v by u. So the minus has become plus. So that is a difference you have to keep in mind while applying for a mirror and for a lens. So m is equal to v by u, not minus v by u. Now to give you a familiar with the sign convention, because as I told you, you have to use the proper sign for the object distance and the focal length. So the sign convention is same as for the mirror. You have to keep in mind that all the distances are measured from the optical center, which is O, and the focal length for convex lens is always positive, and the focal length of a concave lens or diverging lens is negative. So take a proper care for the sign values of u, v, f, and the object height. I'll give you the what are the sign convention. Take a lens, and as I told you, keep the object always to the left of the lens. Okay, so if the object is to the left, so that means left is the negative axis. So the u is always negative because we keep object to the left. So the left is minus x and the right is plus x, because the principal axis is along the x-axis. Similarly, the object is kept perpendicular to the principal axis. So anything along the y-axis, positive y-axis is positive, and anything which is along the negative axis is negative. So if the image is inverted, the h prime becomes negative. And if you see the focal length of a converging lens, because this is principal focus is on the right side, so for a convex lens, focal length is always positive, and for a diverging lens or concave lens, it is negative. So the height of the object, if it is upward, is positive, image downward is negative, and if the image is virtual and upward, then it is positive. So this you have to remember the sign convention like a normal x and y axis. Now the next comes, what is the power of a lens? You have seen this, you have already seen that if you see the converging lens, what the lens is doing? It is bending the light towards the focal point. So power of a lens, it depends upon the focal point, its ability of the lens to bend the light rays. So how much is the bending depends upon the focal length. More is the bending of the light, more is the power of the lens. So we use a formula for defining the power of a lens. Okay, so the power of a lens is the degree of convergence or divergence of the light rays achieved by a lens, and it is expressed in terms of power. So power of a lens actually is defined as the reciprocal of the focal length. So if you know the focal length, take the inverse of the focal length, and that becomes the power of the lens. So the formula to calculate the power of a lens, this is defined by the symbol P. P is equal to 1 by F. The only point is you have to convert F into meter. So if the focal length is given in centimeter, divide it by 100 to get in meter and apply the formula P is equal to 1 by F, and the SI unit of power is diopter. Okay, and it is denoted by D. That means if F is represented in meters, then the power is expressed in diopter. So you can say the 1 diopter is 1 meter inverse. Okay, 1 meter, 1 divided by 1 meter. So this is the SI unit, and this is called 1 diopter. Means if the power of the lens is given as 1 diopter, that means the focal length is 1 meter plus 1 meter or 100 centimeter. So for a convex lens, converging lens, because the focal length is positive, so the power of a convex lens is positive, and for a diverging lens or concave lens, it is negative. Okay, now I'll give you a few examples how to apply the lens formula and find out the object distance. So the question here is a 2 centimeter tall object is placed perpendicular to the principal axis of a convex lens of focal length 10 centimeter. The distance of the object from the lens is 15 centimeter. So you have to find out the nature, position and size of the image, and you have to find out the magnification. So the question comes, how do you solve this problem? So I will explain you. First find out what is given. So in this case is given that it is a convex lens. Okay, so convex lens, just draw a convex lens. Now what is given? So write given. What is given? H is given. So H is the height of the object. So H is 2 centimeter. Then the focal length is given. But focal length is given is not saying whether it is positive or negative. But because the lens is given, lens is a convex lens. So you saw in the sign convention, F for a convex lens is always positive. So F is given. So write F 20 centimeter. Then what is given? The distance of the object from the lens is given. That means U is given. As I told you, U is always taken negative. So U is minus 15 centimeter. right? So these parameters are given. So what you have to find out? Find V, right? Then you have to find H prime, and then you have to find M. So what we have to do is, we have to apply the Lenz formula. So what is the Lenz formula? 1 by V minus 1 by U is equal to 1 by F. So put the value of U and F to get V. So 1 by V minus 1 by U. So U is minus 15. So you write 1 by 15. See here, minus and then U, 1 by U. Since U is minus 15, so you have to write minus 15 is equal to 1 by F. F again is positive and it is 20 centimeter. So plus 20 centimeter. So that means 1 by V minus minus it becomes plus. Okay, now this is a you can simplify this fraction. So 1 by V becomes 1 by 20 minus 1 by 15. So this becomes, you can simplify this, and this becomes 1 by 20. So this becomes 15 minus 20 divided by 20 into 15. So this becomes minus 5 by 20 into 15. So V is equal to minus 20 into 15 by 5. So this becomes minus 60. Just pause. So V is equal to minus 60 centimeter. That means it says the object is 60 centimeter from the lens, and this, now you can find out M. So M is equal to V upon U. So V is minus 60 and U is minus 15, right? So this becomes plus 4. That means magnification is 4 times and the image is virtual. Now you can find out the height of the image. So the height of the image, H prime by H is equal to M. So H prime is equal to M into H. So 4 into 2 centimeter. So into 2. So this is plus 8 centimeter. So the image is, because M is positive, image is virtual, magnified, and the height is 8 centimeter. This is how we solve the problem. Now the next question is, the focal length is given. Find the power of a concave lens of focal length 2 meter. So how do you find out the power? Power is 1 by F. So F is given in meter and this is 2 meter. So this becomes plus 0.5 diopter. So this is how we solve the problem. I'll take one more example, and this example is for the concave lens. Okay, so the problem here is concave lens has a focal length of 15 centimeter. So it is asking at what distance should the object from the lens be placed so that it forms an image at 10 centimeter from the lens. Also find the magnification produced by the lens. So if you see this particular question pertains to concave lens. So what is given in this case? So first we have to write what is given and what we have to find out. So the lens given is a concave lens. So draw a concave lens. Just draw a sketch of a concave lens. What is given? Again the focal length is given. So now focal length is given as 15 centimeter. But you don't know whether this will be positive or negative, because the question will not specify you whether it is a positive or negative. But you know that it is a concave lens, and as I told you, convex lens focal length is always negative. So f you have to write minus 15 centimeter. Now the image distance is given. The image distance given is 10 centimeter. But now if you see the concave lens, the image is always virtual. That means the image is formed on the left side. Okay, the object also is on the left side and the image also is on the left side. So the left side is always negative because it is on the negative x-axis. So you have to be very careful. So the V is given as, you have to write minus 10 centimeter. So what you have to find out? The object distance and the magnification. So you have to find U and M. So again apply the lens formula. 1 by V minus 1 by U is equal to 1 by F. So V is minus 1 by 10 minus 1 by U. F is minus, so minus 1 by 50. So what you have to do is, now this becomes minus minus minus. So you can write 1 by 10 plus 1 by U is equal to 1 by 15. Now you can simplify this fraction. 1 by U is equal to 1 by 15 minus 1 by 10. So this becomes 10 minus 15 into 10. So this becomes minus 5, 15 into 10. So U becomes minus 15 into 10 divided by 5. So this becomes minus 30 centimeter. That means you know that U is always negative. So the object is always kept on the left side. So now the answer is object distance is 30 centimeter from the lens, and you have to find out the magnification. So again apply the formula. M is equal to V by U, right? So the V is negative, minus 10. So minus 10 divided by U, U also is negative. So minus 30 means 1 by 3. So what does positive sign indicates? Is a virtual, and the size is reduced because the magnification is less than 1. So the answer is the image is virtual, demagnified, and the object distance is 20 centimeter. Okay, so now this is your task, and we have completed the topic on reflection and refraction. So your home task is solve all the problems, that is total 17 questions which are given in the NCERT science book at the end of chapter 10, and this has to be written in your journal. So with that I have finished. We have completed the topic on reflection and refraction. We'll go to the next unit, that is the human eyes and the world. So see you in the next class. Thank you for watching the video.